Hi everyone, today in Integrated Math 1, we're going to go over Chapter 5, Lesson 5. Here are the objectives. Make sure you write them down in your notes. So let's go straight to the examples. Solve the absolute value of x minus 6, which is less than 9. Then we want to graph the solution set. So when we're dealing with absolute values, remember we're going to have two cases. So our case 1 is going to be when, in this case, when x minus 6 is a non-negative. So it's going to be the same. It's going to be positive. And then our case 2 is going to be when x minus 6 is negative. So if you recall from before, I always split it so that it reminds me that I have two equations I'm going to be dealing with. So let's go ahead and solve our first one. X minus 6, which is less than 9. I'm going to solve it the same way as I would normally. So box X, add 6 to both sides. So we have X, which is less than 15. And notice when I set it up, X minus 6 was non-negative. I didn't have to change anything. So the only difference between this inequality here and this absolute value one is that I got rid of the absolute value sign because I'm splitting them up in two, so I'm dealing with the inequality here. So our case 2 is a little different. We do see that x minus 6 is negative. So the way we're going to deal with that is we're going to say x minus 6 is going to be multiplied by a negative. But notice it's not just x, or it's not just negative 6. It's x minus 6. Our sign is not going to change. Our sign is not going to change. It's still going to be less than 9. But now I need to use the distributive property. Between this negative sign and the parenthesis is always an imaginary 1 if there's not another number there. So I'm going to say negative 1 times x and negative 1 times negative 6. So negative 1 times x is negative x. Negative 1 times negative 6 is positive 6, which is less than 9. Then we're going to box our x minus 6 to both sides. And then we have negative x, which is less than 3. I still have this negative here, so I'm going to box it. Between the negative and the variable is imaginary 1. So I need to divide both sides by a negative 1. When I divide both sides by a negative, remember, you need to flip your sign. This is a less than, it now becomes greater than. So 3 divided by negative 1 is negative 3. And don't forget to flip the sign. So now I have my two solutions, and now I need to graph it. So let's make a little number line here. And let's say we have 0 here, and we have 15 all the way over here, and we have a negative 3 somewhere close, negative 3. So we have x is less than 15. And notice here that it's just a less than. It's not a less than or equal to. So because of that, you're going to use less ink, which means an open dot. And notice here, the direction it's going to go in is to the left. And just always make sure that your variable's on the left-hand side when you're doing this little trick. And so it's going to go this way. I'll continue it when I see where exactly this graph is going to go. Then I have x is greater than negative 3. Negative 3 is here, and it's going to be an open dot. And notice here, it says it's going to go to the right. It makes that right-hand arrow. So in this case, they're going to collide, and they're going to overlap. So because of that, I also know that this inequality solution is an AND solution. There we go.